In this project, you will teach to learn by animating a specific experiment, concept, or principle. The goal is to create new content and translate information into your own words, sharing what you learn with others. Ancient philosophers and modern educators have long known that one of the best ways to learn something is to teach it to someone else. Research into this protege effect has shown that when we're asked to explain what we've learned, rather than simply memorizing, recognizing, or repeating it, we work harder to understand the material, recall it more accurately, and apply it more effectively. Additional research into teachable agents has demonstrated that students are highly motivated when playing the role of teacher, even when that role is played virtually rather than in person. Students exposed to a teachable agent study the material more conscientiously, are more likely to organize their knowledge, spend more time going over the material, and learn it more thoroughly than students who do not have the opportunity to interact with a teachable agent. This teaching in the context of learning also provides a comparably safe opportunity for students to identify confusions and gaps in their own thinking, and to receive the kind of feedback that further enhances their learning. Questions from peers, instructors, and other teachable agents compel students to think and explain the material in different ways. In this project, you will teach to learn by animating a specific experiment, concept, or principle. The goal is to create new content and translate information into your own words, sharing what you learn with others. You will have the chance to develop skills in animation, solidify new content knowledge, and move beyond remembering and toward abundant opportunities to apply, analyze, evaluate, and produce work that offers deeper learning. The videos in this playlist provide you with some ideas and inspiration.
A Russian physiologist named Ivan Pavlov rang a bell and then gave a dog some food. After repeating this pairing multiple times, the dog eventually treated the bell as a signal for food. The dendrites, the input side of the neuron, receive signals from many other neurons. In most neurons, the dendrites are heavily branched. The cell body contains the neuron's nucleus and all the elements needed for normal metabolic activities of these cells. The axon, finally, is the output side of the neuron. An action potential is generated and travels along the axon to the terminal branches by means of a change in polarity across the membrane of the axon. A woman in Europe was near death from a rare kind of cancer. There was one drug that the doctors thought might save her, but the druggist was charging 10 times what the drug cost him to make. The sick woman's husband, Heinz, went to everyone he knew to borrow money, but he could only get together about $1,000. Heinz got desperate and broke into the man's store to steal the drug for his wife. Questioners developed difficult questions that they knew the answers to, and they presented these questions to the contestants. Both the questioners and the contestants were asked to rate their general knowledge compared to the average student. Questioners didn't rate their general knowledge any higher than the contestants, but the contestants rated the questioners' knowledge higher than their own. He sounded like he was having a seizure and began to gasp for help. If the participant believed that she had been just having a two-way discussion, she was likely to leave her own cubicle to help. But if the participant thought it was a group discussion, the less likely she was to come to the victim's assistance. One individual neuron influences thousands of others, and thousands of neurons can influence one. This is the brain in action.